Virologist Chris Smith joins us now to speak of COVID-19 developments. Morena, Chris.
Hello, welcome, and welcome from lockdown country, lockdown Mark II, here in the wonderful UK,
Right.
with celebrating our 50 to 100,000 cases per day, with probably 618,000 people currently infected all around the country with coronavirus, marking about 1.1% of the population.
So this lockdown is too late then, would you say?
Well, some people are saying it shouldn't have happened at all because they can't really agree on the right way to do this. Because on the one hand, yes, the numbers are quite high, but they're not high everywhere. It's not like when all this began back in March and April, where it was uniformly high because we did genuinely come to the party too late because we didn't know what was happening to us. This time we do, and we have quite a fine-grained mosaic across the country of some areas very high levels of cases, other areas very low. And as a result, many were arguing for the continuation of what had been implemented, which was this system of tiers, with some areas judged to be medium risk and very low-level restriction, other areas very high risk, more restrictive behavioural things going on there. And what then happened is that some graphs were shown predicting that there would be thousands of people dying every day, which have subsequently turned out to be wrong. And as a result, the country was plunged into a lockdown on Halloween. I mean, as if Halloween wasn't scary enough. And here we are with a month of this ahead of us. We're a couple of days in now. And so some people are saying, actually, what we've done is to plunge the entire country under restrictions, with areas where there are very low levels of activity, to control an outbreak in one area, which seems a little unfair on the places that don't have very much virus activity. Some are arguing they should have given the tiers a chance to actually see what they would achieve rather than going and pressing the big nuclear button straight away.
Why do you think they did that then?
Because, and this is rather embarrassing for the government, it turned out that some of the graphs that were being drawn, I mean, there was a press conference on Halloween. It was last Saturday. It was supposed to have been at 4:00 in the afternoon. Then it was 5:00. Then it was 6:00. And I was involved in this because I'd been booked to go on television to react to this press conference. And I think probably whoever was running the newsroom in the BBC would have been climbing the walls by then because they kept on deferring this press conference. But when they actually stood up and we had the Prime Minister and then the Chief Scientific Officer and the Chief Medical Officer for England flanking the Prime Minister, and they were presenting these graphs that half of them didn't fit on the screen. That wasn't terribly good for public understanding of what was going on in the first place when you couldn't see half the stuff. They were hopelessly complicated in some cases, but they made these predictions that subsequently people said, well, hang on a minute, is this actually right? And then when you go back and you look a few days later at these graphs on the government website now, they've been changed and they've been downgraded. And so it looks like there was a much more inflammatory picture perhaps presented to the Prime Minister, albeit an error, we're not saying this is intentional, which may have provoked him to then say, well, we're going to have to do this. When in reality, if he'd seen the graphs as they now are, with much lower, maybe 50, 60% lower predictions on them, they might have said, well, actually, maybe we should give these tiers a chance.
Do you expect to see more surges of the disease and more lockdowns? I mean, what's the end game? Is there an end game here?
Well, I keep asking politicians when I get the chance this question. I ended up on the radio with one of our cabinet ministers, not intentionally. He was on after me, and I said to the presenter, well, hang on a minute, can I have a chat to this guy? Might be interesting. And so I started asking him a few hard questions. And I was asking him, well, what's exactly as you've just asked me, the end game? Where's this all going? And he was saying to me, well, we're going to get a vaccine. And I said, and then he said, well, that'll protect everybody. And I said, but that's predicted for next year. And the number of vaccines that are actually being ordered would be enough to treat less than half the population. What about the other half then? Well, at that point, the interview didn't go any further. And that is the problem, that when you're asking these people this, they're putting all their eggs in a vaccine basket. There is no plan B at the moment, or at least not one that's been voiced to the population, which I think that's a big worry.
Let's talk about the immunity then. There were fears that once you had COVID, the immunity thus conferred didn't last for very long. But there are a few studies out now suggesting the contrary.
Well, I spoke last week to Wendy Barclay. She's a virologist at Imperial College, and she's one of the authors of the REACT study. The REACT study is a very large study. They've mailed out tests to hundreds of thousands of people across the country. These individuals test themselves for antibodies, and then they take a photo of the test result, which is a lateral flow assay, a bit like a pregnancy test, and it then gets logged. And this made headlines last week because what they showed is that when people did this test in June, they returned a value of about 6% of people were testing positive. They then repeated the test a number of times, but by the time of the last outing of the test, a few months later, that number had fallen to 4%, suggesting that about a quarter of the people they were testing no longer had antibodies detectable to the coronavirus. Now, the deduction from that is, well, if you don't have antibodies that are detectable, you might be susceptible to catching the virus again. Because in tests that have been done, if you have a certain level of antibody that's registrable by one of these tests, in animal studies, that happens to correspond to animals that are protected, apparently, from reinfection with the virus. When you have levels that correspond to a negative test result, so you can still have a bit of antibody, but not enough to register on the test, those animals appear to be susceptible to reinfection with the virus, suggesting that those people who no longer test positive may be susceptible to reinfection, but we don't know that for sure. And of course, in the meantime, since we last spoke, there's been quite a lot of attention focusing around individuals who are now being or becoming published case studies of individuals who are definitely catching coronavirus more than once. The big question is, though, do these people who have low levels of antibody and are not registering a positive on these tests, are they genuinely susceptible again, or are they just under the threshold for the test, but they have enough immune memory that were they to encounter coronavirus again, actually they'd be okay? And at the moment, we don't know the answer to that critical question.
The people who appear to have contracted the disease again, do they get sick or as sick the second time?
Both. And you might say that sounds confusing, Chris. But actually, if you look at the case reports, there are a number of them now, and about half of the case reports document someone who is very sick the second time round, and the other half document an individual or individuals who are not very sick the second time round. I spoke recently to the researchers in Texas who looked after a man in his early 20s who was one of the case reports documented in The Lancet a couple of weeks ago. And their patient had coronavirus insufficiently badly to take him off to hospital, but he did get a test and was positive. He recovered uneventfully and was okay for about 48 days, and then he caught it again and had similar symptoms, and this time was much more dramatically affected, sufficient to then take him off to the doctor, who put an oxygen probe on his finger and said, "Wow, you need to be in hospital," and sent him off to hospital where they tested him, and he had coronavirus again. Now, cynics would say, oh, well, he just had the virus all along. It's just it disappeared below the level of detection for a while and it's resurged for some reason. Actually, the researchers sequenced the genetic code of the virus on both occasions, lined them up side by side, and could prove that these were two different strains of virus that infected him 48 days apart. And in his case, so he was someone who got it again, but he got it the second time much worse than the first time. On the other hand, you take the case of the patient, the Hong Kong patient as he's now known, gentleman who had relatively mild symptoms the first time round, took him off to hospital, got a test, discharged uneventfully, recovered. 3 months later, he's returning having holidayed in Europe, ironically, goes through Spain, then Heathrow, returns to Hong Kong, is tested at Hong Kong as an asymptomatic screen, positive. And again, sequencing the virus genetically and lining up the virus the first time he had it and the code from the virus the second time he had it, they are two different strains of virus, proving reinfection, but the second time, no symptoms whatsoever. So we really don't know what's going on in these people.
But it does not bode well for the vaccine, surely.
Well, I asked Wendy Barclay that, and I said, and actually the researchers from Texas, and I said to them, what's your interpretation? What would you predict for the vaccine? Because obviously a person just looking at this at face value would say, well, if you can test positive for this virus and within fewer than 3 months, having had a positive antibody test, catch it again, what are your prospects of being long-term immune? If the virus itself can't make you immune, what hope does a vaccine stand? And actually, they both made almost the same point, which is, it's a good one, which is that many viruses have evolved over thousands to millions of years to become extremely good at sidestepping our immune response. So the viruses pack quite a punch. They use various strategies to avoid stimulating your immune response or even damp down your immune response. So catching the virus itself naturally does not necessarily translate into such good immunity as a vaccine unencumbered by those mechanisms of thwarting your immune response will produce. So actually there's all good reasons to be optimistic. A vaccine won't have the same constraints placed upon it that natural infection would. Nevertheless, we don't know how long your immunity is to any kind of coronavirus at all anyway, vaccine or natural infection. So at the moment it's very much we have to wait and see.
So a vaccine is not merely see, I always thought a vaccination was to fool the body into thinking that they had minor version of the illness so the body could react to it. You're saying that there is something about a vaccine that is extra protective.
We do a number of things when we vaccinate people, and one of the things we do is to often include things called adjuvants or other effectors in there that are designed to really give your immune system a kick up the backside. So it really strongly stimulates it, so you make a really profound response. Now, one approach to doing this is what you do is you deliver the right parts of the virus, but you do it in the context of a different virus. And this is what Oxford University and AstraZeneca have teamed up to do. Their ChAdOx vector system uses a chimpanzee cold virus, an adenovirus, and they've removed a couple of key genes from there that enable it to grow. So this is a virus that cannot grow in the body, but they've put into it the gene that tells it also how to make the outer coat of the new coronavirus. So when you're infected with that virus, it can infect once, it goes into cells, and it turns on various viral genes, including this make me look like a coronavirus gene. And that means you educate your immune system as though you've really been infected with that virus. But a lot of the things that would make that virus bad or enable it to grow have been removed. So it just stimulates your immune system very powerfully as though there's a real virus there, but there isn't. And it makes you make both antibodies as well as T cells that are capable of recognising the presence of this foreign entity. So you do get, they're saying, quite a good response to that vaccine.
Point of fact, actually, I don't know whether you can answer this or whether it's always the same, but when is a person who has contracted COVID-19 on day one, when are they infectious?
We're learning more about this all the time. And initially, we took the view that with things like flu, where we kind of have a lot of familiarity with that infectivity probably peaks alongside symptomatology. This has been revised, and we now understand that you are maximally infectious for about 3 days or about 3 days before the symptoms. And by the time the symptoms kick in, your infectivity is beginning to dwindle. So the median incubation time is about 5 days. So a person is probably becoming infectious from 2 or 3 days before then. And they're at maximum infectivity, but may have no symptoms at all. And this is why this virus has been such a headache to control, because half of people, it turns out, have no symptoms whatsoever at any point. So they're not going to go and get a test, because as far as they're concerned, they're hale and hearty right as rain, but they're probably infectious. And the other half of the people that are going to have symptoms, nevertheless, they're walking around potentially infecting people because they're shedding virus before they have any symptoms. And this has made it really difficult to control this thing when you do your control measures the way we have as a world been doing it, looking for symptoms and using that to trigger testing, and then using those test results to follow people up. Because you're going to miss half your people, because half of people have no symptoms, they get no test.
This seems quite aside from anything else, a kind of bad planning on the part of the virus, because if a virus makes you cough, then I thought that that was a way that the virus had of spreading. But if it's most spreadable before the symptoms, then what's the point of the coughing, if you see what I mean?
Well, coughing certainly does help to spray out viruses, and some viruses do induce cough or through irritation of your airways, secondarily induce cough. But you don't just have to cough to spread things. Remember, coughs and sneezes spread diseases, so sneezing will do it too. This virus doesn't cause much sneezing. It doesn't cause much upper respiratory symptomatology in that way. But it doesn't stop you breathing. And when you breathe, shout, scream, sing, all those things, they lead to the release from the body of clouds of droplets. And they can include virus particles, naked viruses, but also respiratory droplets, blobs of water from the airways. And if there's virus growing on the airways, it will end up packaged into those droplets and you can spray them out into the room. And they will hover for a period of time in the air and other people can breathe them in. They can land on surfaces. If people touch those surfaces, they get them on their skin. And if they then rub their eyes, pick their nose, even eat their lunch, pick up your sandwich with the hand that you were touching the computer keyboard that someone else touched, you can transfer enough virus, because we think the infectious dose is pretty low, maybe as low as 10 virus particles, and it's in, because it's into your nose and throat where cells that are susceptible to infection are, and it can get in and infect you.
Do we know, it's a question from a listener, how long after first infection the virus can be detected in a test?
Right. Well, people go positive when they're shedding virus from a couple of days. So from about 2 days prior to them actually developing symptoms, they are demonstrably, as in on a test, positive. That's the case. And you can continue to detect virus in someone who's mildly infected, as in they don't have very severe symptoms or no symptoms, under 10 days. Beyond 10 days, there have been no cases where individuals are shedding virus still that's viable. So it looks like the most infectious period is from 2 days before you get symptoms, if you're going to, and not beyond 10 days in an otherwise mild manifestation.
But if I have the swab stuck up my nose, how long after my very first infection does my body start producing sufficient evidence for the swab to detect the virus? Do you know what I mean?
Yes, you begin to test positive from as soon as a day or two after infection. But it varies. Some people have been detected as an incubation period of 1 day. Others, it's taken an average 5 days. So from the minute you're infected, you start the process of making virus particles, but you only make enough virus particles after a threshold amount of time for the virus to have grown enough to go positive on the test, and then for the test to have swabbed sufficiently well to pick up enough virus to reach the detection threshold of the test. And for that reason, we think we might be missing 20 or 30% of the positives when we swab people, because we're testing too early, or people have insufficient virus there at all for that test to detect.
Gotcha. A couple of minutes left. Who knew Denmark was the world's biggest mink?
I didn't know.
But anyway,
I didn't know until a couple of weeks ago when this began to happen.
You do now. How worried should we be about this variant that has infected 12 people and it seems to be spread by mink in Denmark?
Denmark, enormous producer of mink. Mink, a mammal very similar to us in many regards, which is why, like ferrets and other animals that are susceptible to this new coronavirus, they can catch it. When you've got farmed animals kept in very high density, they can spread diseases very quickly. They can also produce high infectious burdens. That means a human who's in contact with them is going to be exposed to a lot of virus and it could infect that person. And we see this happening a lot. Take bird flu, for an example. So the big question, therefore, is what is the threat to people from these mink? And the answer is, I went poking around saying, well, what is this mutant that they're talking about? I couldn't find any published information on it. I phoned up a friend of mine, Sarah, at Cambridge University. She's a vet. She works on animals' immune responses to emerging pathogens and things. She couldn't find any evidence published on what this mutant is. So we're not really sure whether this is a lot of press speculation with a grain of truth, or a lot of information that just hasn't actually come out yet and they're all feeding off a press conference. We don't know exactly what this entity is, but we must watch it and we must be careful for the simple reason that there is the potential to amplify large amounts of virus. Also, the question of this being an animal reservoir. If it gets into nature and gets into animals, it's very hard to eliminate from anywhere because you can't go and cull every animal in every country.
Thank you, Chris. Chris Smith, good luck in the lockdown,
Thanks,
by
Kim.
the way.